Bienvenidos, Ushamdi, and welcome. CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or the Scaling Networks V6 course from the Cisco Networking Academy. And this evening's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 2.2.2.4, where we now take a look at troubleshooting Inter-VLAN routing. So let's go ahead and dive in. Again, the topology is very straightforward and very simple. To the right here, we have our addressing table. And this is information that we are going to be referring to often when we go through to check things out. So we've got some straightforward objectives: locate the problems, implement the solutions, and then verify network connectivity. Well, it really doesn't tell us where we should be starting. So with troubleshooting, we're going to typically start at layer 1 if we're doing a bottom-up approach in terms of trying to determine what may be wrong. And we see we've got, from a layer 1 perspective here, it's kind of nice in Packet Tracer. The lights are flashing green, so everything looks good there. If we transition to layer 2, now, what are my layer 2 constructs? Well, the VLAN is a layer 2 construct. And if we're talking about inter-VLAN routing issues, right, we can see that we've probably got router on a stick here. And since we know that when you're doing router on a stick, on the interface on the router side, we need to make sure we have that VLAN encapsulation statement, right? That incap.1q with the VLAN identified on the sub interface. So in other words, gig 01.10 or gig 01.30. So let's start with the VLAN setup. So we can see fast Ethernet 011 and 06 here on switch 1. And my guess is, unfortunately, for whatever reason, the activities are, with the switches anyway, extremely small in terms of the text. The router will be different. So we go from user exec to privilege exec with the en or the enable command. And let's go ahead and do some quick validation. So I'm going to say show Vlan Brief. Again, starting with the layer 2 construct, we want to confirm, is VLAN 10 created and what ports are in VLAN 10? So let me slide this over just a skosh. And there we go. So VLAN 10 is 172.17.10.0/24. So fast Ethernet 011 is in the faculty staff VLAN 10. Then we have VLAN 30, which is our guest or default, and that's fast Ethernet 06. So let's do a quick show run. And we can also see that interface fast Ethernet 06 is in VLAN 30 via this method. Now, what we're looking for here as well is let's make sure that we've got the switch port mode access command on both of these ports, and we do. So on the switch, everything appears from at least the VLAN perspective to be correct. Now, what's the other layer 2 construct on the switch that we need to be concerned about if things are going to be working here? Right, so we know we have router on a stick as our inter-VLAN method. And as a quick review, remember that there's 3 basic approaches to inter-VLAN routing. We can do this router on a stick approach that we have here, where we do sub interfaces on gig 01. If we weren't doing router on a stick, we could configure that port as an access port and put it in VLAN 10. And then if we had gig 00, we could bring that down and plug that in and put that as an access port here in VLAN 30, right? So in other words, we'd be dedicating an individual physical port on the router per VLAN. And this is a valid approach as well, right? So you can do both approaches, the router on a stick, or we can dedicate individual ports. Now, typically, what's going to happen is you're not going to have that many ports on your router. So what you're probably going to look to do is the router on a stick approach like we're doing here, where we create, as you can see, the sub interfaces were up over here behind that window. So that's two approaches. The third approach would be, and actually would be that we get rid of the router and switch 1 is a multi-layer switch, like a 3560, although these are legacy, or a 3650, these are the newer Catalyst switches that actually run iOS XE, or we've got the 3850, right? So in terms of stackable switches like the 3560, which again is legacy, you've got the 3650 and the 3850, and these are layer 3 capable. And the typical rule of thumb is the first number in the model number indicates the highest layer that that switch can operate. So again, a 2950, right, or a 2960, and they've got some models of the 2960 now that are the 2960 XR, where you can, and that R is for routing, you can run OSPF or EIGRP and things like that. So things are definitely changing, but again, a general rule of thumb is that that first number in the model number indicates the highest layer that that switch would operate at. And so when you see a 2950 or 2960, typically it's going to be layer 2. And then when you look at the 3650 and the 3850, it's typically layer 3. So we could make that a multi-layer switch and eliminate the router altogether. So those are 3 approaches that we've got when we're talking, or that we have when we're talking about Inter-VLAN routing. And so router on a stick, we know that this interface on the switch, gig01, needs to be what kind of an interface? We validated the VLANs are here, right? You can clearly see we've got VLAN 10, VLAN 30. So since we have multiple VLANs traversing that traversing that link, and gave you the answer, what kind of a link does, or what kind of a port does this need to be here on switch 1? Exactly. It needs to be a trunk link. So let's go ahead and scroll down a little further here on the switch, and let's investigate gigabit Ethernet, gigabit Ethernet 01. Well, it's very tiny, but it says switch port mode access. Now, we discussed this in class, and if that is an access port, and you can see there's no switch port access VLAN command here, what VLAN is the router currently sitting in here? Exactly, it would be the default, because again, remember, 99.9% of the time, if it is a default setting on a Cisco router or switch, it will not show up in the config. You need to know what that default setting is, right? Other examples, we talked about switch port security, where if you don't say anything for the violation, it's going to be a shutdown, right? If you leave it blank. Same thing with the maximum. If you don't put anything for the maximum, it's going to be 1. And so here, we don't see that access, the switch port access VLAN statement, so it's VLAN 1, the native VLAN and the default VLAN. So again, right now this is an access port. We know that that's wrong. It needs to be a trunk port. So let's go ahead and get into global config here. And we say config T or conf T. And then I'm going to get an interface gigabit Ethernet 01. I'm going to say switch port mode trunk. Now, if I say switch port trunk incap.1q, we get an error because this is a 2960, I believe. Yes, it's simulating a 2960 with LAN base. So by default, it's going to be do show interface trunk. It's by default going to have an encapsulation of 802.1q, and you can see that right there. And we've got the native VLAN as VLAN 1. Now, what I might also want to do, since I said switch port mode trunk, let's turn DTP off. We'll say switch port no negotiate. And let's take it one step further. I'm going to say switch port trunk allowed VLAN, and I'm going to list the VLANs that are allowed to traverse this trunk. We'll say 1, 10, and 30. And that's it. So because again, we've only got 2 VLANs, 10 and 30, that are quote unquote, user VLANs. It's, I think, faculty and students or something like that. But then we'll allow VLAN 1 to come across the trunk as well, because we're currently using that as our native VLAN. So and in fact, let's do this. We'll switch this up again. So let's say switch port trunk native VLAN 999. So we'll even change it. And then let me pull this back and we'll say, we'll just do 10, 30, and 999. So when I say do show run, right, you can see that there is the trunk port, right? So we're all set. VLANs 10 and 30 are allowed to go over the trunk. The completion percentage is a little off to the side. Let me see if I can shrink this window just enough. And again, the only command that was probably required here is simply that switch port mode trunk. That would have probably been enough, but we'll take it a little further, right? Let's go a little deeper down the rabbit hole and talk about some of the best practices and some of the things that you should be looking to do. And that is certainly a set of commands there that you would definitely be looking to implement. All right, so we've taken care of the trunk port. So we know we have a trunk port on the switch side, but then we also, and we can almost guarantee that they're going to be tricky here on the router and try to create some chaos. And take a look at that. It's unfortunate that the switch windows for the CLI are not cooperating with the large text, like the routers are here. So this is much easier, and I'm actually glad that it looks like we're going to have more troubleshooting on the router than we are the switch. So here we are in router 1, and let's go from user exec to privilege exec with the enable command, or just en, and then we'll say show IP interface brief. Right, so let's take a quick look at the interfaces here. Now we can see right away that something's not right, and what we see is this administratively down. Right, so we clearly see that there's an issue here. So let's go ahead and do a show run and take a look at the subinterface gig 01.10, because it's clear that we've got a problem. So here it is, Gigabit Ethernet 01.10. We've got our IP address, and first let's take a look here at this incap.1q30. Now, this is typically where they will try to trip you up. And here's how they do it. The sub-interface number, right, does not need to match the VLAN. Okay, so this could theoretically work, although we're not using the right subnet here. But remember that this sub-network interface number does not need to match the incap.1q statement, and it does not need to match the VLAN that's being used. So keep that in mind. The two things that need to match are the incap.1q30, that's indicating what VLAN tag am I looking for. And here, subinterface 1.10 says it's looking for .1q30. The only problem with that is that it should be VLAN 10. And so what does have to match is the subnet coming from the VLAN, whatever that VLAN number is, in this case 10, needs to match the incap.1q number. And you can see the third octet of your IP is typically used to sort of line up with your VLAN number. So it should be incap.1q30, and so you can clearly see here that what they're trying to do is trip you up with reversed incap.1q statements. Now, I'll be interested to see, because I've had to deal with this before, I'll be interested to see when we go to remove or to switch this, what I think we're going to have to do is change this one to something like 44, just to anything other than 10, and then come down and change this statement so that it's 30. Now remember, the sub-interface numbers do not have to match the VLAN or the incap.1q statement, but they should. Because I talk about troubleshooting all the time, right? And trying to make things easier for the people that follow you once you're gone or once you're not there or on vacation. And anything you can do to prevent your phone from ringing when you're on vacation is a plus. So while the sub-interface numbers don't have to match the VLAN, they should. They always should. In fact, both of these ports should have a description in here that just basically says VLAN 30 sub-interface, VLAN 10 sub-interface, to make it even easier if someone comes in. They can look at that and say, oh, this is the student's VLAN or the faculty or the management or the HR department or whatever the case may be, right? So we've got to reverse the incap.1q statement. So let's take care of that first. And like I said, I'll be interested to see, we go into global config with configure terminal. I'm going to go into the sub-interface gigabit Ethernet 01.10 first. Now, if I say incap.1q30, I should see some sort, 10, incap.1q10, I should see some sort of an error. And you would see this on a real Cisco router that telling you that you cannot, under the same sub-interface, have the same encapsulation set. So in other words, I can't have incap.1q10 on both gigabit Ethernet 01.10 and 01.30 at the same time. All right, fantastic. So there you go. Configuration of multiple sub-interfaces of the same main interface. And what that means, the main interface is gigabit Ethernet 01. With the same VLAN ID, 10 in our case, is not permitted. It's already configured on gigabit Ethernet 01.30. So, as suspected, let's just change it to 50, right? It doesn't matter what we change it to as long as it's not what's currently configured on gig 101.30. So now that I've changed it to 50, to something other than 10, let's go down to interface gigabit 01.30, where we need to say incap.1q30. And remember, what we just did there is we changed it from incap.1q10 to the correct value of incap.1q30. So now I can go back into interface gigabit Ethernet 01.10 and put the incap.1q10 command in. And you'll notice we don't get the error that we had previously received. Now, the bigger issue here is the interface, the sub-interface, I should say, for gigabit Ethernet 01.10 is shut down. So let's say no shut, and we bring that interface up. So let me go ahead and pop out here real quickly, right? And we say show run. And so we're still sort of dealing with these layer 2 issues, right? The incap.1q statement, the trunk port. We have an interface that's shut down. And let's real quickly take a look at the IPs. 172.17.10.1 is correct. 172.17.30.1 is correct. And we come down and that looks like everything on the router. So let me drop this down. So we've still got something that's outstanding, right? You can clearly see that we don't have all of our points. So let's check our PCs to see what the PCs look like here. See if we've got any errors on our PCs. Oops. All right, let's go to our desktop and our IP configuration. So the PC should be 172.17.10.10. /24 172.17.10.1 is our default gateway, and so that's correct. Let's take a look at PC3 in VLAN 30, and we've got 172.17.30.10 as our IP, and that is correct. The right subnet mask. Aha, and here we are. Our default gateway is 172.17.10. but this is on VLAN 30. And so this should be the IP address. And remember, the default gateway for these PCs is going to be the sub interface on the router for that VLAN. And we know that it's .1, right? 172.17.10.1 and 30.1. So now that it looks like we've got all of the troubleshooting done, let's go ahead and test our connectivity. So can I route between VLANs? Let's see, can I ping 172.17.10.10? In other words, can PC3 ping PC1? So the first request timed out, we probably had to send an ARP packet out to get the MAC address of our default gateway because we don't have that in our ARP cache, right? So we send out that address resolution protocol request saying, hey, I know my default gateway because we configured it, right? We configured it right here. So the ARP request goes out and says, hey, I'm trying to get to 172.17.30.1. If you are 172.17.30.1, please respond to me with your MAC address. That way I can craft the frame that's going to go to your NIC or network interface card, and I need to have that information, right? That layer 2 MAC address information is required. So that's what that ARP request does, is it says, whoever is 172.17.30.1, please respond to me. I need your physical layer 2 MAC address so that I can construct the frame, ship it over to you, and then you can handle it from there. All right, and so we're good there, the PCs, yeah, and so that's it. So we can ping each other, right? PC1 can ping PC3 and PC3 can ping PC1, and those were the issues. And so what did we see? We did the bottom-up troubleshooting approach. We took a look at layer 1. We saw that we had all green lights, and so everything looked good, right? Maybe a little misleading, though, on the gig 01.10, right? Because that sub-interface was shut down. However, the main interface is what gives us our green lights here. So layer 1 looked good. We took a look at layer 2. We took a look at the trunk ports. We took a look at the VLAN configuration. We did a little extra configuration on that trunk port. And then we went up to the router and we took a look at the sub interfaces, and we saw that the ncap.1q statements had been reversed. So we fixed those. Then we no-shut the sub interface gig 01.10. And then we took a look at the configuration on the PCs and noticed that at layer 3, the IP address, or I should say the default gateway on PC3 was wrong. All right, well, that is going to wrap up this packet tracer tutorial and solution set for packet tracer activity 2.2.2.4. Appreciate you watching. Hopefully this has cleared up any confusion you may have had while you were working through this activity. And I will see you on Tuesday evening. Have a great night.